Hello, I'm Sophia Richter, and I'm going to be solving a probability and expected value problem. So in this problem, a character named Jenny is at a fair, and she's going to be spinning this wheel 3 times. And we want to figure out the probability of each outcome and the expected value. So the best way to figure out the probability is to make a tree. So let's start making the tree. So first we have 2 options. So let's make one set of branches, kinda. So the first option is that, let's say we get green or blue. But it's important to note what's the probability that this is going to happen. So green, as you can see here, and as it says in the problem, makes up 75% of the board, which means basically 3/4 probability. So I can say that right here. And blue makes up 1/4. So now, our next option is again green or blue, but this can branch out from green and blue. So let's do that. So we got green or blue and green or blue. Once again, the probability of this is 3/4 and 1/4 and 3/4 and 1/4. And this probability doesn't change because when you spin the spinner, the probability won't change because it's not like you're taking anything out of a bag. It's not like you're altering the probability in any sort of way. It's always constant. So finally, our third spin, we have kind of 4 options to go through, but it's still green or blue. So I can branch that out here, being as neat as possible. So that's one option. That's another. That's one option, and that is another. So, green or blue, green or blue, green or blue, and green or blue. This is the third spin, kind of. So, I mean, you get the idea. It's always going to be 3/4, then 1/4, 3/4, then 1/4. I can just label that really small, but it's good that we have an understanding of what that means. So 1/4 and 3/4 and 1/4. Okay, so now how many outcomes are there? I see 1, 2, 3, 4, 5, 6, 7, 8. So 8 different outcomes. So we have to figure out the probability of each outcome. But it's important to note that order doesn't matter. And why do I say that? Well, what does order mean? Order would mean GGB versus BGG. So in both of these, I have 2 greens and 1 blue, but the order is different. So if I were to be, drawing something out of a bag and not replenishing what I've drawn out, then order would matter because the probability is changing. But as you can see here, the probability here is never changing. So I'm basically saying 3/4 times 3/4 times 1/4 is equal to 1/4 times 3/4 times 3/4, which is true. So order does not matter. So what I mean to be saying is, let's look at this. GGB would be the same thing as BGG right here. So I'm just gonna try to find exactly how many options there are. So I think this is its own option. So I'll circle this thing. GGG, there's only 1 GGG on the board. And same with this, there's only 1 BBB on the board. I guess I should say on the tree. But now let's get into GGB. I can circle that because that's the first one I've seen. Because that's 2 G's, 1 B. And then I got GBG, which once again it's 2 G's, so that's not an option. Then I got GBB, that can be an option. You got 2 B's, 1 G. So that's 1, 2, 3. That's 3 options, and the fourth one down there. Then BGG, that's already an option because we already have that up there. So I can cross that off. And we got BGB, that's already an option. We already have that because 2 B's. So don't need that. And then we got BBG, we already have that. So I only get 4 options because, once again, order does not matter. So basically, I have 4 options. So now I need to figure out the probability of that. Okay, here's how you find the probability of the 4 outcomes. Okay, so my first outcome is where I get 3 greens. So I'm just going to explain everything here to make it less confusing. So 3 greens, and why do I have 3/4 to the power of 3? Well, the probability of spinning a green is 3/4. So as you make your way through the tree, you have to multiply 3/4 times 3/4 times 3/4 to get 42.2%. So that's what I did. So the probability of that is 42.2%. Now for GGB, GBG, BGG, we already established that they're the same thing because order doesn't matter. But I still thought to just include them. So for this, I did 3/4 to the power of 2 first because green, green. There are 2 greens, so I did that to the power of 2. Just like for this, there are 3 greens, so I did the probability of green to the power of 3. Makes sense? Kind of see the pattern here. And then I did times 1/4 because you have that blue. You can't forget that blue. You have to multiply it by 1/4. And then I did times 3. Why? Why didn't I do this one times 3? Because there are 3 possible ways of getting 2 greens and 1 blue, right? 1, 2, 3. For the 3 greens, there's only one possible way. So basically, I was multiplying this by 1, which I didn't even need to put. So I did this to get the same thing, 42.2%. Cool. So now I have GBB, BGB, BBG, which we've established that order doesn't matter, but it's still important to include these. So I did 3/4, basically to the power of 1, because there's 1 green, but can't forget that green. Then I multiplied that by 1/4 to the power of 2, because there are 2 blues. Multiply that by 3 because of the same reason of the previous one. There are 3 possible ways to get 2 blues and 1 green. So I multiplied it by 3 to get my answer as 14.2% probability. Finally, we have BBB, 3 blues. This is going to be pretty simple, kind of like GGG, where you have 1/4, which is probability of getting a blue, spinning a blue, and then you cube that, basically, to get 1.6%. So those are my 4 probabilities of my 4 outcomes. So now, that's how you find the probability of each. You're halfway done with the problem, basically. But you need to find the expected value. And how do you do that? Well, I will show you. So, basically, the first step to finding the expected value for me is that I want to find out, for each of these outcomes, these 4 outcomes, how much money am I making? How much money will I make if I get 3 green, if I get 3 blue? So let's figure that out. How do we figure that out? Well, it's going to be pretty simple. We have 3 green, and if you look at our wheel, then you'll see that 3 green will be $1, $1, $1, which is equal to $3 because you're adding that all together. $3. But hey, you have to remember that each spin costs $1. And you're doing 3 spins, multiply that by $1, it costs $3. So you got to subtract that. So look at that. We got $0, unfortunately. But hey, let's try these other ones out. So now this one, you have basically 2 green, 1 blue. Let's look at our chart. We have 2 green, $1, $1, and 1 blue. That's $6 because 1 plus 1, $6 plus 4. Let's go here, write $6. Subtract 3 because that's how much it costs to get $3. So, you know, it's not $1 million or anything like that, but we're getting there. Now let's try 1 green and 2 blue. Go back to over here. That's $1 plus 4 plus 4. That gets you $9. So that's more. That's good. $9 minus $3 gets you $6. Wow. Okay. Finally, BBB, 3 blue. 4 times 4 times, or not times 4, sorry. 4 plus 4 plus 4 is equal to $12. Awesome. That gets you $12. Subtract $3 to get a profit of $9. So now you're starting to kind of find the expected value. The way you find the expected value is by multiplying the likelihood of each outcome by the amount of money you get from each outcome. Does that make sense? So I'm going to do that down here. I'm going to make a big equation and just do that. So I'm going to take my probability, 0.422 times 0, which, you guessed it, it's equal to 0, but I'll still include it, plus 0.422, I'm using this one now, the second outcome, times $3 basically, because that's how much money I'm making, plus 0.142 times 6, and plus 0.016 times 9. Let's calculate that. So when I calculate that all together and add it all together, I get my answer to be 2.262. Now this has to be in dollars, and that's not going to work in dollars, so I can round up and say that equals $2.26. So in other words, you get so basically the expected value means that when you play the game, the average amount, kind of like the amount you're most likely to get, is going to be $2.26. So, I mean, that's better than nothing, you know, definitely. I mean, it'd be great for it to be higher. But, you know, if I were you, I would play the game. Because, you know, you could get higher, you could get lower, but your expected value is okay. So, go for it, you know. Win $2.26. So, I hope everything makes sense. I hope you know how to find the expected value now. All you do is you multiply the outcome, the probability of the outcome, times the amount of money you'll get from each outcome. That's the expected value, which is here. And then just finding the probability, you can use your magnificent tree to find the amount of outcomes and like whether or not order matters or not, you know. But yeah, so in conclusion, I hope you understand everything, and I hope you have an amazing day. Bye.